Hey there. I wanted to take the opportunity to demonstrate a project I've been working on for a while and hopefully dispel what, at least to me, appears to be a bit of incorrect information persisting on the internet. My purpose in this project was to control a Bioloid robot from the Beaglebone Black without using any external hardware or occupying the only available USB port on the device. I'm going to go ahead and run the project now just to show it in action. As you can see, I have an AX-12 connected to the Beaglebone, and I have the software configured to repeat a motion from one of the Motion 512 files over and over. What you're seeing on the screen is an external connection to the Beaglebone, with the Beaglebone connected to my wireless network via a nano USB adapter connected to the one USB port on the Beaglebone. And I have all of this running from a homemade battery pack. The image you're seeing on the right side of the screen here is coming from a cheap OV7675 camera that's also connected to the Beaglebone. As I mentioned at the beginning, I wanted to dispel what at least appears to me to be an incorrect assertion I've seen on the internet, and that's that the Beaglebone can't control a Dynamixel from its onboard serial port at 1 megabit. This is not correct, as I'm right here controlling a Dynamixel from the Beaglebone UART at 1 megabit. In this case, it's the UART that's part of the PRU ICSS, and I'm using one of the PRUs to feed the motion data at 1 megabit to the Dynamixel 128 times a second. So at the very least, the PRU UART can control the Dynamixels at 1 megabit. The same may be true of the UARTs that are part of the main application processor, but I haven't tested them. I think the belief that the UARTs can't do 1 megabit may come from a misinterpretation of the technical reference manual, where they list some register value settings and the resulting baud rates. I think they were meant as a guide to show what settings produce what baud rates, but not to suggest that these were the only baud rates supported by the UART. I think the misunderstanding may also come from developers who've only attempted to use the UARTs under control of an OS, where the OS may be limiting what baud rates it will allow, or automatically adjusting baud rates to what it considers standard. As I mentioned a moment ago, I'm using a PRU to control the UART that's controlling this Dynamixel. And I've actually been able to control 15 servos in the puppy configuration, although I have had some problem with noise on the line, preventing it from enumerating 1 or 2 servos in the configuration. And I said I wanted to be able to do this without using any external hardware. The only bit of what you can consider external hardware is this right here. That's just a small board I put together to arbitrate access to the serial bus. Basically, the Beaglebone UART is a full duplex. It has a pin for transmit and one for receive. The Dynamixels use a half duplex configuration. One line is used for both transmit and receive. So I needed something to be able to arbitrate access to the bus, and this board is literally just a couple of tri-state buffers and a couple capacitors and a resistor, and that's it. Basically just like a couple dollars worth of hardware. And as I mentioned, I'm using a PRU to control the UART that's controlling the Dynamixel. If you're familiar with the Beaglebone, you've probably heard about the fact that the Satara processor has a programmable real-time unit integrated industrial control subsystem. And that consists of 2 PRUs, which are essentially 2 200 megahertz microcontrollers that can run independently from the main processor without an OS, and that have access to system resources like memory and peripherals. And the ICSS part consists of various peripherals, and one of those is UART, and that's what I'm using here. Is I have one PRU using the UART from the ICSS to control the Dynamixel, and I have the other PRU controlling this camera. And as I said, this camera is just an OV7675, which you can pick up for about $5. So basically you're seeing a $5 camera, $50 Beaglebone, few dollars worth of parts for something to arbitrate the bus, and a homemade battery pack that costs about $30 to build. So for less than $100, you're looking at a pretty powerful system that can be used to control a robot and that you can access remotely by way of a network connection. There you're seeing the camera picking up my hand and the office that I'm working in. You can see that the processing, the CPU time on the Beaglebone is getting chugged through pretty hard, but that's probably because the code that I'm using for handling the video processing is far from optimized. This is actually OpenCV, an OpenCV produced window that you're seeing getting the feed from the camera. I have made the source for everything available through SourceForge, and I will be including some more notes along with this video. Thanks for taking a look.